Okay, 3 grams of hydrogen and 24 grams of oxygen are present in a gas mixture at a constant temperature and pressure. The partial pressure of hydrogen is 1/3 of the total pressure, 2/3 of the total pressure, 3/2 of the total pressure, like that. Here 3 grams of hydrogen and 24 grams of oxygen are taken in a vessel. Calculate the partial pressure of hydrogen. Here 3 grams of hydrogen means calculate the number of moles of hydrogen. Number of moles of hydrogen is equal to weight of hydrogen by the molecular weight of hydrogen. So weight of hydrogen is 3 and the molecular weight of hydrogen is 2. So number of moles of hydrogen is 1.5. Then like that, calculate the number of moles of oxygen. Number of moles of oxygen is equal to weight of oxygen by its molecular weight. That is 3/4. Then the total mole number of oxygen, not oxygen, hydrogen and oxygen. That's number of moles of hydrogen plus number of moles of oxygen. It is 1.5 plus it is 0.75. That is 2.25. Now the question is, the partial pressure of hydrogen is the total pressure of hydrogen into mole number of hydrogen by total mole number of hydrogen plus oxygen. Here the total pressure is not given, so let us take that the total pressure is total pressure into mole number of hydrogen is 1.5 by total mole number of hydrogen plus oxygen 1.5 plus 0.75, that is 2.25. That is the partial pressure of hydrogen is equal to the total pressure into 15 by 22.5, or 7.5 2s are 7.5 3s are. Therefore partial pressure of hydrogen is equal to the total pressure into 2/3. So in that mixture the partial pressure of hydrogen is the 2/3 of the total pressure. So I want to extend the problem. In the question, what will be the partial pressure of oxygen? If the partial pressure of hydrogen is 2/3, the partial pressure of oxygen is 1 minus 2/3. That is equal to 1/3. Yes, check the answer. 3 grams of hydrogen, 2/3 of the total pressure. The second option is correct. Yes. Let's come to the fourth one. A mixture contains 4 grams of hydrogen, 42 grams of nitrogen. The fraction of the total pressure exerted by the nitrogen, the same model as the previous one. Here 3 grams of hydrogen, 24 grams of oxygen are taken in a gas mixture, the partial pressure of hydrogen. Here 4 grams of hydrogen, 42 grams of nitrogen are taken. The fraction of the total pressure of nitrogen, same 3/7, 4/2, 3/2, the same model. You can answer it easily. Then come to the fifth one. If 1000 milliliters of gas A at 600 torrs and 500 ml of gas B at 800 torrs are mixed in a 2-liter flask, what will be the total pressure of the gas mixture? It is somewhat different formula. Just I will explain. If two gases of different volumes and different pressures are mixed in a container, for example, V1 milliliters of a gas A at a pressure of P1 and V2 milliliters of another gas at a pressure of P2 are mixed together. Mix it together. Then the pressure of the gas mixture, the resultant pressure of the gas mixture is P1 V1 plus P2 V2 by the total volume of the gas mixture. It is the formula. Yes. Please understand. If two different volumes of gases at different pressures are mixed in a container, then the total pressure of the gas mixture is P1V1 plus P2V2 by total volume. P1 is the pressure of the first gas and V1 is its volume. And V2 is the volume of second gas and its pressure is P2. And if the two are mixed in a vessel whose volume is V, then the total pressure of the gas mixture is P1V1 plus P2V2 by total volume. In our previous question, here 1000 milliliters of gas A at 600 torrs and 800 milliliter, 500 milliliters of gas B at 800 torrs are mixed in 2 liters vessel. So P1 V1 plus P2 V2 by the total volume, that they are mixed in 2 liters volume, total volume. It gives answer. Therefore, here the first gas 1000 milliliters into 600 torrs P1 V1 plus P2 V2 500 milliliters of another gas at 800 torrs P2 V2 taken in 2 liters vessel. 2 liters vessel means 2000 ml. Therefore, the pressure of the gas mixture is equal 600 into 1000 plus 500 into 800 by 2000. That means 6 into 10 power 5 plus 4 into 10 power 5 by 2 into 10 cube, or 6 by 2 into 10 square, or that is 300. Not 300. 6 into 6 plus 4 into 10 by 5. Here that 6 plus 4 here 6 plus 4 into 10 power 5, 6 plus 4 into 10 power 5 by 2 into 10 power 3, that is equal to 10 into 10 power 5 by 2 into 10 power 3, that is equal to 5 into 10 square or 500 torrs. Ready? A question? Fifth one. 500 torrs is the answer. So again, the formula, if two gases of different volumes and different pressures are mixed, then the mixture of the pressure of the gas mixture is equal to P1V1 plus P2V2 by total volume. Or if more than two gases are mixed together, then P1V1 plus P2V2 plus P3V3 plus P4V4 so on PnVn by the total volume. That's all. As coming to the next one. Sixth one. In the gas mixture, 1 gram of hydrogen, 5 grams of helium are mixed in a 5 liters vessel at 20 degrees. Calculate the total pressure. Very direct question. 1 gram of hydrogen, 5 grams of helium. So we can calculate the number of moles of hydrogen, number of moles of helium. Are mixed in a 5 liters vessel. Volume is given at 20 degrees centigrade. Temperature is given. Calculate the total pressure of the mixture. We know that the total pressure of the gas mixture is equal to total number of moles of the gases present in the mixture into RT by V. Here, how many grams of hydrogen is given? 2 grams of hydrogen, not 2 grams. 1 gram of hydrogen, 5 grams of helium. 1 gram of hydrogen and 5 grams of helium. You can calculate the number of moles. Number of moles of hydrogen is equal weight of nitrogen by its molecular weight 2, and the number of moles of helium is equal to weight of helium 5 grams by its molecular weight. So it is 0.5, it is not point, it is 1.2, is it 2? కాదు కదా 10 1.25. Then the total pressure is equal to total mole number 0.5 plus 1.25 1.75 into R 0.0821 into temperature is given as 20 degrees 20 plus 273 Kelvin 293 by what is it volume. How many liters of vessel is taken? Taken 5 liters vessel. 5 liters vessel means the volume is 5. Remember, the R value is taken in liter atmosphere per degree per mole. Therefore, volume must be expressed in the liters only, 5 liters. Calculate this one. It gives the total pressure. Just you have to calculate this one. So the answer may be, so calculate it, you will get the answer. As next one, the 7th one. In 1 liter flask at certain temperature, there are 2 grams of hydrogen, 8 grams of oxygen. The mole fraction of oxygen, here the mole fraction is given or asked, not the partial pressure or the total pressure. Just calculate the mole fraction of oxygen in a given mixture of 2 grams of hydrogen and 8 grams of oxygen. What is mole fraction? What is mole fraction? Mole fraction of a gas is equal to mole fraction of a gas is equal to mole number of that gas by total mole number of all the gases present in the mixture. Here, in our problem, only 2 gases are there. That is 2 grams of hydrogen and 8 grams of oxygen. 2 grams of hydrogen and 8 grams of oxygen. The mole fraction of oxygen, calculate the mole fraction of oxygen. Mole fraction of oxygen is equal to mole number of oxygen by the total mole number. That means number of moles of oxygen and number of moles of hydrogen. So number of moles of hydrogen is equal to weight of hydrogen by the molecular weight of hydrogen, that's 1. And the mole number of oxygen is equal to 8 grams is given, 8 by 32, that is 1 by 4 or 0.25. Therefore, the mole fraction of oxygen is equal to mole number of oxygen 0.25 by the total mole number of hydrogen plus mole number of oxygen, that's 1.25. That is 25 by 125. 25 by 125. That is 1 by 5 or 0.2 is the answer. 0.2 is the answer. Then coming to the next one. A vessel contains methane and oxygen in the mass ratio of 2:1. In our first problem, equal mass of SO2 and O2 are taken. But in the 7th problem or 8th problem, a vessel contains methane and oxygen in the mass ratio of 2:1. The fraction of partial pressure of oxygen in the pressure. Here, the methane and oxygen are taken in the 2:1 ratio, methane to oxygen 1. Methane and oxygen are taken in 2:1 mass ratio. Then the partial pressure of methane or partial pressure of oxygen we can calculate. First, take the number of moles of methane. Number of moles of methane is taken as 2 because the mass ratio. Because mass ratio, instead of mass you may take mass ratio because it is a relative or comparison. Therefore, the number of moles of methane is equal to 2 by 16 and the number of moles of oxygen is, the mass ratio is 1. So, 1 by 32. Therefore, the partial pressure of methane is equal to total pressure into mole fraction of methane. Mole fraction of methane means mole number of methane by total mole number. The total mole number is equal to 2 by 16 అంటే 1 by 8 plus 1 by 32. That is equal to 5 by 32. Therefore, the partial pressure of methane is equal to total pressure into mole fraction of methane. Number of moles of methane is 1 by 8 by total mole number 5 by 32. Like that, calculate it, you will get the answer. Yes, coming to the next one. Two identical vessels are filled with 44 grams of hydrogen and 44 grams of oxygen and equal masses. It's nothing but the first question. If the partial pressure of the CO2 is 2 atmosphere, the partial pressure of hydrogen is just 2 equal weights are taken. Calculate the number of moles of hydrogen and calculate the number of moles of oxygen. Because the partial pressure of one gas is given, you can calculate the partial pressure of another gas. Yes, in the 10th question, oxygen and helium are taken equal weights in the vessel. Again, equal weights are taken. Same question. The pressure exerted by helium in the mixture is the same question as the first question. That's all. These are the first 10 questions. In this exercise, there are 20 questions. Remaining 10 questions are in the same model. Try to answer it. If you get any doubt, send the question number through WhatsApp. Then I will send the answer, or again I will explain the remaining questions in this evening and upload another video by this evening. Okay, thank you.